Hello and welcome to the channel. Tonight we're stepping into the quiet world of infinite possibilities. Picture reality as an endless library, where each book contains a universe, and somewhere in those countless volumes, every story that could ever be written already exists. We find ourselves wandering these hushed corridors of existence, where the very fabric of space and time whispers of other worlds just beyond our reach. Tonight we explore whether these parallel realities are mathematical dreams or profound truths, mysteries that unfold one patient moment at a time. I hope this video isn't too interesting, though if it does happen to keep you awake, at least you'll be learning something fascinating in the process. Not the worst way to spend a sleepless night. Before we begin, if you enjoy drifting off to the gentle hum of science, I'd be very grateful if you tap the like button and subscribe to the channel. It helps more sleepy minds find their way here. And while you're settling in, I'd love to know where you're watching from and what time it is for you right now. Feel free to share it in the comments. It's always wonderful to see how far these quiet little journeys reach. So get cozy. Let your shoulders relax. Let your thoughts slow down like cosmic dust, settling across the vast emptiness of space. Have you ever made a decision and wondered what would have happened if you'd chosen differently? Perhaps you stood at a crossroads, literally or figuratively, and felt the weight of paths not taken. Maybe it was something small, like which coffee shop to enter on a rainy Tuesday, or something profound, like whether to take that job offer that would change everything. There's something haunting about those moments, isn't there? The lingering sense that somewhere, somehow, another version of your story is unfolding. This feeling isn't just nostalgia or regret. It might be something deeper, an intuition that touches the very fabric of reality itself. Because what if those other choices, those other paths, those other versions of you, what if they're all real? What if this universe, with all its galaxies and mysteries, is just one note in an infinite symphony of existence? Tonight, we're going to explore one of the most beautiful and bewildering questions in all of science. Does the multiverse exist? It's a question that sits at the intersection of cutting-edge physics and ancient philosophy, where mathematics meets dreams, where the smallest particles dance with the largest cosmic structures. It's a question that makes some of the world's brightest minds argue passionately. And it's a question that might change how you see everything around you. But here's the thing about great questions. They're never really about finding a simple yes or no answer. They're about the journey of wondering, the process of stretching our minds around ideas so vast they make our everyday concerns seem beautifully small and perfectly significant all at once. So let's begin this gentle exploration together. Like astronomers pointing their telescopes not outward toward distant stars but inward toward the very nature of existence itself. What if this universe is just one of many? Imagine you're looking up at the night sky from your backyard, wrapped in a blanket, feeling small beneath the endless canopy of stars. Each point of light represents a sun, many with their own family of planets, stretching across distances so vast that light itself, the fastest traveler in our universe, takes years, decades, even millions of years to cross the space between them. It's already overwhelming to think about. This one universe of ours with its 100 billion galaxies, each containing hundreds of billions of stars. But what if this entire cosmos, everything we can see, measure, or even imagine, is just one bubble floating in an infinite ocean? What if reality is so much larger than we ever dared to dream? The idea isn't new, though it might surprise you to learn that some form of multiverse thinking has existed for thousands of years. Ancient Hindu texts spoke of infinite universes, each one breathing in and out like cosmic lungs across endless cycles of time. The atomist philosophers of ancient Greece, like Democritus, imagined countless worlds scattered throughout infinite space, each one the unique arrangement of the basic building blocks of reality. But it wasn't until the 20th century that this ancient intuition began to find its way into the equations of physics. It started quietly, almost accidentally, when physicists trying to understand the behavior of atoms stumbled upon implications that stretched far beyond their laboratories. They were like cartographers who set out to map their local neighborhood, and discovered they were living on just one small island in an archipelago that extends beyond any horizon. The multiverse isn't just a single idea. It's more like a family of related concepts, each born from different corners of physics. Some emerge from quantum mechanics, where the fuzzy behavior of particles at the smallest scales suggest reality might be constantly branching like an infinite tree. Others arise from cosmology, where our understanding of the universe's beginning hints at cosmic inflation spawning countless other universes like bubbles in champagne. There's something both humbling and exhilarating about this possibility. Humbling, because it suggests that everything we know and love, every sunset, every conversation, every moment of joy or sorrow, might be just one tiny note in a symphony, so vast we can barely comprehend it. Exhilarating, because it opens up vistas of possibility that stretch our sense of wonder to its breaking point. And that brings us to something fascinating about human nature. We seem to be the kind of creatures who can't help but ask these ultimate questions. We're not content to simply exist. We need to understand the stage upon which our existence plays out. We're like children who keep asking why and what if until we reach the very edges of what's knowable. But what makes the multiverse idea particularly intriguing is that it's not just philosophical speculation anymore. It's emerging from the mathematics of our best theories, the same equations that predicted black holes before we found them, that described the behavior of light before we understood photons, that revealed the expansion of the universe before we had telescopes powerful enough to see it. So as we embark on this journey together, we're not just indulging in cosmic daydreaming, we're following a trail of mathematical breadcrumbs that some of the most brilliant minds in history have left for us, leading toward ideas that challenge everything we thought we knew about the nature of reality. The question, what if this universe is just one of many, isn't just asking about space and time and matter. It's asking about the deepest nature of existence itself. It's asking whether reality is generous beyond our wildest dreams, whether the cosmos has room not just for everything that is, but for everything that could possibly be. Infinite space, infinite outcomes, the logic of many worlds. Have you ever shuffled a deck of cards and wondered about all the different ways they could have been arranged? There are more possible arrangements than there are atoms on Earth. A number so large it makes infinity feel almost cozy by comparison. But here's where it gets interesting. If space is truly infinite, then somewhere out there, every possible arrangement of those cards exists, not just once, but infinitely many times. This isn't just a card game thought experiment, it's pointing towards something profound about the nature of reality itself. If the universe is infinite in extent, and if matter and energy are distributed throughout it roughly as they are in the region we can observe, then the logic becomes inescapable. Everything that can happen must happen, not just once, but infinitely often. The reasoning is surprisingly simple, like a mathematical proof that starts with everyday observations and arrives at mind-bending conclusions. Matter comes in discrete units, atoms, molecules, particles, and these units can only be arranged in a finite number of ways within any given volume of space. It's a large number, certainly, but it's finite. If you have a finite number of possible arrangements spread across infinite space, then repetition becomes not just possible, but inevitable. This means that somewhere out there, there's another version of Earth, not just similar to ours, but identical in every detail. Or same mountains, same oceans, same history unfolding moment by moment. And on that Earth, there's another version of you, reading these same words at exactly this moment, having exactly the same thoughts. It's like the universe is an infinite library where every possible book exists, including perfect copies of the one you're reading right now. But the implications stretch even further. If every possible arrangement exists, then there are also Earths where history unfolded differently. Worlds where the dinosaurs never went extinct, where Shakespeare wrote different plays, where you made that other choice at that crucial moment in your life. The multiverse becomes not just a collection of space and matter, but a vast catalogue of every story that could ever be told. Ancient philosophers intuited something like this. The Roman poet Lucretius wrote about infinite worlds where nothing that is produced in one place is unique to that place alone, but he could only imagine it. We're living in the first generation that might actually be able to think about it scientifically. The mathematics here is both beautiful and strange. When you're dealing with true infinity, not just a very large number, but actually infinite space, the usual rules of probability start behaving in unexpected ways. Events that are incredibly unlikely still become absolutely certain to occur, not just once but infinitely often. It's like having infinitely many lottery tickets. Eventually you're guaranteed to win every possible jackpot. This creates what physicists sometimes call the measure problem, when everything possible happens infinitely often. How do you calculate probabilities? How do you make predictions? It's like trying to count the number of even numbers versus odd numbers in the set of all integers. Both sets are infinite, so which one is bigger? But perhaps that's not the right question to ask. Perhaps the beauty of this type of multiverse lies not in its predictive power, but in its expansion of what we mean by existence itself. If reality is this generous, this abundant with possibilities, then maybe our usual categories of real and hypothetical start to blur together. There's something oddly comforting about this vision, like discovering that the universe has room for every dream, every story, every possible version of every possible life. It suggests that nothing is ever truly lost, that every moment of beauty, every act of kindness, every flash of insight exists somewhere in the vast tapestry of infinite space. And that brings us to something worth pondering as you drift into sleep tonight. If infinite space means infinite possibilities, then somewhere out there's a universe where this conversation we're having right now is the most important moment in that version of your life. Somewhere, this gentle exploration of cosmic mysteries is exactly what another version of you needed to hear at exactly this moment. Quantum forks, when every choice creates a new reality. Picture this: you're standing in your kitchen, reaching for 2 cups of tea. One is chamomile, which will help you sleep. The other is black tea, which will keep you awake. In the classical world we think we inhabit, you choose one, drink it, and live with the consequences. But quantum mechanics suggests something far stranger and more beautiful. You choose both, not metaphorically, but literally. According to one interpretation of quantum physics, an interpretation that has led some of our deepest thinkers to the idea of infinite parallel worlds, every quantum choice creates a branching point in reality itself. At the moment you reach for your tea, the universe splits. In one branch, you drink chamomile and drift peacefully to sleep. In another, you drink black tea and stay up reading. Both versions of you continue existing, each in their own equally real branch of reality. This isn't science fiction. This is the many worlds interpretation of quantum mechanics first proposed by physicist Hugh Everett III in 1957. Everett was trying to solve a puzzle that had been bothering physicists for decades. Why does the quantum world, which is ruled by probabilities and uncertainties, collapse into the definite classical world we experience every day? In the quantum realm, particles exist in what physicists call superposition. They're in multiple states simultaneously until they're measured or observed. It's like a coin that's spinning in the air, neither heads nor tails, but somehow both until it lands in your palm. But here's the mystery. We never see superposition in our everyday lives. Coins land either heads or tails, never both. Cats are either alive or dead, never the famous quantum combination of both that Schrödinger's thought experiment suggested. Most interpretations of quantum mechanics say that measurement somehow collapses the superposition, forcing the quantum system to choose one state or another. But Everett had a different idea. What if nothing ever collapses? What if superposition continues forever, but the universe branches to accommodate all possibilities? Imagine reality as an ever-branching tree, where each quantum event creates a new fork. Every time a particle could go left or right, reality splits to allow both. Every time an atom could decay or remain stable, the universe branches to accommodate both outcomes. Every time you make a choice, even one that feels entirely classical, quantum events in your brain create new branches of reality. The implications are staggering. If Everett was right, then every possible version of history is playing out simultaneously. There are branches where World War II never happened, branches where you were born in a different century, branches where the laws of physics themselves are slightly different. It's nice having infinite parallel novels, all being written at once. Each one equally real, each one continuing the story from every possible choice point. But here's what makes this particularly beautiful. In this interpretation, nothing is ever truly lost. That friendship that ended badly, there's a branch where you worked it out. That opportunity you missed, there's a branch where you took it. That person you loved who loved someone else, there's a branch where your story had a different ending. Some physicists find this interpretation wasteful. All those worlds, all that existence, just to explain why we see definite outcomes instead of quantum fuzziness. But others find it elegant in its very extravagance. Why should reality be stingy? Why shouldn't the universe be generous enough to allow every possibility to unfold? And there's something deeply personal about the many worlds interpretation. It suggests that every version of yourself, the confident one, the uncertain one, the one who took risks and the one who played it safe, all of them are real, all of them are you, all of them are living out their stories in their own branch of the quantum tree. As you lie in bed tonight, quantum events are occurring in your brain with every thought, every dream, every flutter between sleeping and waking. If Everett was right, each of these quantum events is creating new branches of reality. So, perhaps, as you drift off to sleep, you're not just ending one day, you're beginning countless new stories, each one exploring a different path through the infinite garden of possibility that reality might truly be. The many worlds interpretation transforms the question what if from hypothetical to actual. What if you had made different choices? According to quantum mechanics, you did. They're all real. They're all happening. They're all you. The bubble universes of eternal inflation. Imagine blowing soap bubbles on a summer afternoon. Each bubble starts as a tiny disturbance in the soapy film, then rapidly expands into its own perfectly spherical world, complete with swirling patterns of color that dance across its surface. Now imagine that this process never stops, that new bubbles keep forming, expanding, creating their own self-contained realms, each one slightly different from all the others. This isn't just a pleasant childhood memory. It might be the most accurate metaphor we have for how reality actually works at the largest scales imaginable. According to the theory of eternal inflation, our entire observable universe, with all its galaxies, stars and planets, is just one bubble in an infinite ocean of cosmic foam, with new universe bubbles constantly forming, expanding and evolving in their own unique ways. The story begins in the first fraction of a second after the Big Bang, in a period so brief that light couldn't even cross the distance of a single atomic nucleus. But in that impossibly short time, something extraordinary happened. Space itself began to expand exponentially, doubling in size again and again at a rate that would make your head spin if you could somehow watch it happen. This period is called cosmic inflation, and it explains some puzzling features of our universe. Why space appears flat on the largest scales, why the cosmic microwave background radiation is so uniform across the sky, why we don't see certain exotic particles that our theories predict should have been created in the Big Bang. Inflation stretches away all these potential problems like pulling tight a wrinkled bedsheet until it appears perfectly smooth. But here's where it gets really interesting. Once inflation starts, it might never completely stop. While most regions of space exit inflation and become normal expanding universes like ours, other regions keep inflating, creating new space that can itself undergo its own inflationary episodes. It's like a cosmic chain reaction where each expanding region has the potential to spawn new expanding regions forever. In this picture, our Big Bang wasn't the beginning of everything. It was just the moment when our particular patch of space stopped inflating and began evolving into the universe we see around us. Elsewhere in the cosmic foam, other Big Bangs are happening all the time, each one giving birth to a new bubble universe with its own unique properties. And that's where things become truly mind-bending. Each bubble universe doesn't just have its own space and time, it might have its own version of the laws of physics, the strength of gravity, the mass of electrons, the way nuclear forces hold atoms together. All of these might be different in other bubbles. Some universes might be filled with stars and planets and perhaps life. Others might be dark and empty. Still others might be so different from ours that we couldn't even begin to imagine what they're like. The ancient Greeks had a word for this kind of thinking, apeiron, meaning the infinite, or the boundless. The philosopher Anaximander used it to describe the source from which all things come, and to which they return. He could never have imagined that modern physics would arrive at something so similar, an infinite, boundless realm that constantly gives birth to new worlds. There's something both humbling and wonderful about eternal inflation. Humbling, because it suggests that our entire observable universe, vast as it is, represents just the tiniest fraction of what exists. All of human history, every star we can see, every galaxy our telescopes can detect, all of it is contained within one small bubble in an infinite cosmic foam. But it's also wonderful, because it suggests that existence is incredibly abundant. If eternal inflation is real, then the cosmos isn't just generous. It's extravagantly, impossibly generous, constantly creating new realms of space and time and matter and energy. It's like discovering that reality is not just one story but an infinite library where every possible story is constantly being written. As you settle into sleep tonight, you might think about the fact that if eternal inflation is correct, new universes are being born at every moment. Somewhere in the cosmic foam, space is stretching and expanding, creating the conditions for new Big Bangs that will give rise to new stars, new planets, Maybe new forms of life having their own bedtime thoughts about the nature of existence. And perhaps that's the most beautiful thing about the bubble multiverse. It suggests that the creative power that gave birth to our universe, that moment of expansion and cooling that led to atoms and stars and planets, and eventually to you lying in bed, pondering these mysteries, that creative power never stopped. It's still happening, still creating, still filling reality with new possibilities. The edge of our universe, and the possibility of others. Have you ever stood at the edge of the ocean and tried to see the horizon? That mysterious line where water meets sky. There's something both peaceful and thrilling about knowing that beyond what you can see, the ocean continues, stretching toward distant shores you'll never visit. Our universe has something like a horizon too, but it's not a boundary in space. It's a boundary in time and light. Picture this. You're looking up at the stars, and you're not just seeing across space, you're seeing back in time. The light from each star has traveled for years, decades, centuries, or even millennia to reach your eyes. When you look at the Andromeda Galaxy, you're seeing it as it was 2.5 million years ago. You're literally looking into the cosmic past. But there's a limit to how far back you can see, and it has nothing to do with the power of your telescope. It has to do with the age of the universe itself. Light from the most distant objects we can observe has been traveling for about 13.8 billion years. Essentially since the universe became transparent enough for light to travel freely through space. Beyond that lies what astronomers call the cosmic microwave background, the afterglow of the Big Bang itself. This creates our cosmic horizon, the edge of the observable universe. It's like standing in the middle of a vast foggy field where you can only see a certain distance in any direction. But here's the intriguing question. What lies beyond the fog? What exists beyond the edge of what we can possibly see? One possibility is surprisingly mundane, more of the same. If the universe is uniform on the largest scales, then beyond our cosmic horizon might simply be more galaxies, more stars, more planets, arranged in patterns similar to what we observe in our local cosmic neighborhood. It would be like discovering that the ocean continues beyond the horizon, pretty much the way you'd expect. More water, more waves, more of the same vast blue expanse. But there's another possibility that's far more intriguing. What if the universe is not uniform on the largest scales? What if the region beyond our cosmic horizon is fundamentally different from the space we can observe? This isn't just speculation. It emerges naturally from our best theories of cosmic inflation. Remember that period of rapid expansion in the universe's first moments? Different regions of space might have exited inflation at different times, or under different conditions. This could create what cosmologists call pocket universes, regions beyond our horizon, where the laws of physics might be different, where the fundamental constants that govern the behavior of matter and energy might have different values. Imagine the cosmos as a vast patchwork quilt, where each patch represents a different region with its own unique properties. Our observable universe would be just one patch in this infinite quilt, surrounded by other patches that we can never see or visit, but which are just as real as our own. Some of these pocket universes might be hostile to life as we know it. In some, gravity might be too strong for stars to form. In others, the forces that hold atoms together might be too weak for complex chemistry to develop, but others might be even more conducive to life than our own universe, with conditions that allow for forms of existence we can barely imagine. There's something poetic about the idea that we live in a universe with invisible neighbors, beyond the farthest galaxies we can see, beyond the cosmic microwave background, beyond the very edge of what light has had time to show us. There might be other realms of existence, other stories unfolding, other forms of consciousness pondering their own cosmic horizons. Ancient mariners used to believe that beyond the edge of their maps lay unknown lands filled with wonders and dangers. Here be dragons, they would write at the edges of the known world. Today's cosmologists face a similar situation, but instead of dragons beyond the edge of their maps, there might be entire universes. And here's what makes this particularly fascinating. We might never be able to prove what lies beyond our cosmic horizon, but we can still think about it scientifically. We can use our understanding of physics to make educated guesses about what those invisible realms might be like. We can explore them mathematically, even if we can never visit them physically. As you drift towards sleep tonight, you might find it comforting to think that beyond the edge of everything we can see, reality continues. The creative forces that made our universe, that led to stars and planets and life and consciousness, might be operating in countless other regions, creating countless other possibilities for existence. The horizon isn't an ending, it's just the boundary of the visible. Beyond it, the story of existence continues to unfold in ways we can barely begin to imagine. Strings and brains, parallel realms in higher dimensions. Close your eyes and imagine you're an ant walking along a telephone wire. From your ant's perspective, the wire appears one-dimensional. You can only move forward or backward along its length, but you, watching from your human vantage point, know that the wire exists in 3 dimensions. It has width and depth that the ant cannot perceive, cannot access, perhaps cannot even imagine. Now consider this. What if we humans are like that ant? What if the reality we experience, with its familiar 3 dimensions of space and 1 dimension of time, is just a thin slice of something much larger and more complex? What if there are entire realms of existence unfolding in dimensions we cannot perceive, parallel to our own world, but separated by gaps smaller than the smallest thing we can measure? This isn't science fiction. It's one of the most elegant ideas in modern theoretical physics, emerging from string theory, the attempt to describe all the fundamental forces and particles in the universe as tiny vibrating strings rather than point-like objects. And it suggests that the multiverse might not just be out there in distant regions of space, but right here, right now, separated from us by dimensions we cannot access. String theory requires extra dimensions to work mathematically. Not just the 4 we experience, 3 of space plus time, but 10 or 11 dimensions in total. Where are these extra dimensions hiding? The most common explanation is that they're curled up so small that we can't detect them, like the thickness of that telephone wire when viewed from far away. But there's another possibility that's even more intriguing. What if some of these extra dimensions are large, possibly infinite, but we're simply trapped in our familiar 4-dimensional slice of reality? In this picture, our entire universe, every atom, every star, every galaxy, might be like a shadow cast past the wall of a much higher dimensional reality. This leads to the concept of brains, short for membranes, which are like multi-dimensional surfaces floating in the higher dimensional space that physicists call the bulk. Our universe might be a 3-dimensional brain embedded in a space with many more dimensions, like a soap bubble floating through air that has depth the bubble itself cannot access. If this is true, then there could be other brains floating nearby in the bulk, separated from us by distances measured not in miles or light years, but in extra dimensions. These other brains could contain their own universes, complete with their own matter, energy, space, and time. They could be right next to us in the higher dimensional sense, but completely inaccessible from our 4-dimensional perspective. It's like imagining multiple sheets of paper stacked on top of each other, with entire universes drawn on each sheet. Beings living in one sheet couldn't interact with those in another sheet, even though the sheets might be separated by only a tiny distance in the 3rd dimension. But sometimes, these brain universes might interact. When 2 brains collide or come close together in the bulk, it could create spectacular effects that we might detect as cosmic events in our own universe. Some theories suggest that our Big Bang might have been the result of just such a collision. 2 brains bumping into each other in higher dimensional space, releasing the energy that became our expanding cosmos. There's something beautifully humble about this vision of reality. It suggests that no matter how vast our universe appears to us, it might be just one thin slice of something infinitely richer and more complex. All the galaxies we can see, all the space between them, all the dark matter and dark energy that makes up most of our cosmos. All of it might be confined to our particular brain, while parallel universes unfold on other brains that we can never reach or even directly detect. Ancient Platonic philosophy spoke of our world as shadows cast by perfect forms existing in a higher realm. The brain multiverse offers a scientific echo of this ancient intuition. What we experience as complete reality might be just a shadow of something far more fundamental existing in dimensions beyond our perception. And yet, there might be subtle ways that these parallel brains influence each other. Gravity, alone among the fundamental forces, might be able to leak between brains, creating tiny but detectable effects in our universe. Dark matter, that mysterious substance that outweighs ordinary matter, but barely interacts with it, might actually be ordinary matter living on a nearby brain, influencing our universe through gravitational effects that cross the dimensional gap. As you settle into sleep, consider that according to these theories, there might be other versions of reality existing right here, where you're lying, separated from you by dimensions curled up smaller than atoms or stretched out beyond your ability to access. Other beings might be having their own bedtime thoughts, just a fraction of an inch away in the fifth or sixth dimension, as unreachable as if they were on the far side of the universe. The brain multiverse suggests that reality is not just larger than we imagine, it's structured in ways that stretch the very meaning of larger and smaller, near and far. Mirror universes. Could another you be listening right now? There's a moment that happens to almost everyone. You catch a glimpse of yourself in an unexpected mirror, and for just an instant, you don't recognize the person looking back. They have your face, your clothes, your expression, but something feels different, foreign, as if you're seeing a stranger who happens to look exactly like you. What if that feeling isn't just a trick of perception? What if it's a glimpse into something deeper about the nature of reality itself? In the strange landscape of multiverse theories, one of the most personally unsettling ideas is the possibility of mirror universes, realms where everything is not quite the same, but not entirely different either. These aren't the quantum parallel worlds we explored earlier, where every possible version of history unfolds simultaneously. These are universes that might be almost identical to ours, but with subtle differences that create an eerie sense of familiarity mixed with wrongness. The concept emerges from several different areas of physics. In some versions of eternal inflation, the random quantum fluctuations that determine the initial conditions of each bubble universe might occasionally produce regions that are nearly identical to our own. It's like shuffling an infinite number of decks of cards. Eventually, you'll get arrangements that are almost the same, differing by just a card or two. In other theories, mirror universes arise from symmetries in the laws of physics themselves, just as your left hand is a mirror image of your right hand, similar in shape, but opposite in orientation. There might be entire universes that are mirror images of ours, where the basic forces and particles have opposite properties but otherwise behave in familiar ways. Imagine walking through such a mirror universe. The stars would shine in familiar constellations, but perhaps they'd be made of antimatter instead of ordinary matter. Planets would orbit in the same patterns, but time might flow slightly differently, or gravity might pull with a slightly different strength. Cities might exist in the same locations, but built from materials that look right, but feel subtly wrong when you touch them. And then there's the most unsettling possibility. In a mirror universe, there might be another version of you. Not a quantum parallel self living out different choices, but a mirror self who made all the same decisions, had all the same experiences, learned all the same lessons, but exists in a context that's shifted just enough to create an uncanny valley effect when you try to understand them. This mirror version of you might be listening to these same words right now, having the same thoughts, feeling the same sense of wonder and unease at the idea of mirror universes. But maybe their universe has a slightly different value for the speed of light, or the mass of the electron is fractionally different, creating subtle changes that ripple through the structure of reality in ways too small to notice, but profound enough to matter. There's something both comforting and disturbing about this idea. Comforting because it suggests that the patterns of existence, the way matter organizes into complexity, the emergence of life and consciousness, the development of intelligence capable of pondering its own existence, might be robust features of reality that appear again and again across different universal contexts. But disturbing because it raises questions about identity and uniqueness that cut to the core of what it means to be human. If there's another you in a mirror universe having nearly identical thoughts, which one is the real you? Are you both equally real? Are you the same person, or different people who happen to share identical histories? Philosophy has grappled with these questions for centuries, but the multiverse gives them a scientific context that makes them feel more urgent. In a reality where mirror universes might actually exist, the question of personal identity becomes not just philosophical speculation, but a potential scientific inquiry. Some theories suggest that mirror universes might occasionally interact with our own, in subtle ways. Perhaps déjà vu isn't just a trick of memory, but a momentary glimpse of your mirror self's experiences bleeding through some dimensional boundary. Perhaps those dreams that feel more real than reality are actually windows into parallel experiences unfolding in nearly identical contexts. Or consider the strange phenomenon that psychologists call the uncanny valley. The unsettling feeling we get when something looks almost human but not quite. What if this reaction evolved as a response to occasional encounters with beings from mirror universes? Entities so similar to us that they trigger our recognition systems, but different enough to set off alarm bells that something isn't quite right. As you lie in bed tonight, you might wonder whether somewhere in a mirror universe, another version of you is also lying in bed, having nearly identical thoughts about the possibility of mirror universes. Perhaps they're wondering about you in the same way you're wondering about them. Perhaps this very moment of mutual wondering is happening simultaneously across multiple mirror realms, creating a kind of cosmic echo where the same thought reverberates through slightly different versions of reality. The mirror universe concept suggests that identity might be both more fragile and more robust than we imagine. Fragile because it depends on the specific context in which it arises. Robust because the patterns that create it might emerge again and again across different realms of existence. The multiverse in mathematics, patterns beyond imagination. Have you ever looked at a snowflake under a magnifying glass and marveled at the intricate patterns that emerge from simple rules? Each one is unique, yet they all share certain underlying symmetries, six-fold structures that arise not from design, but from the way water molecules naturally arrange themselves when they freeze. Mathematics has a similar quality. Simple rules and relationships give rise to patterns of breathtaking complexity and beauty, structures that exist in the realm of pure logic before they ever appear in the physical world. What if the multiverse itself is like this? Not primarily a physical phenomenon, but a mathematical one. What if all possible universes exist simply because they can be described mathematically, and mathematics itself is the deepest level of reality? This idea isn't as strange as it might first sound. After all, the most successful theories in physics are fundamentally mathematical. When Einstein described gravity as the curvature of space-time, he wasn't just using mathematics as a tool to describe something physical. The mathematics was the description. The equations didn't point to reality, they were reality, expressed in its purest form. The mathematician Max Tegmark has taken this insight to its logical conclusion. He suggests that mathematical structures don't just describe physical reality, they are physical reality. Every mathematically consistent structure corresponds to a universe, and every universe that exists does so because it can be described by some mathematical framework. In this view, our universe exists because the particular combination of equations that describe quantum mechanics, relativity, and the standard model of particle physics form a mathematically consistent structure. But there are infinitely many other mathematical structures, each one equally valid, each one describing a universe that is just as real as our own. Some of these mathematical universes might be similar to ours, governed by slightly different versions of familiar physical laws. Others might be so alien that we couldn't even recognize them as universes in any sense. We understand there could be mathematical realities where time has multiple dimensions, where causality runs backward, where the very notion of space doesn't apply. Think about the number line that you learned in school, the infinite sequence of integers, fractions and irrational numbers that stretches in both directions forever. This mathematical structure exists independently of any physical implementation. You don't need to build it out of atoms or energy. It simply is by virtue of being logically consistent. Now imagine that every possible mathematical structure has the same kind of existence, and that physical reality is just what it feels like to be inside one of these structures from the perspective of a conscious observer. This mathematical multiverse would be truly infinite, containing not just every possible universe, but every possible kind of universe. There would be universes that follow the rules of classical physics, quantum physics, or physical laws that we haven't even discovered yet. There would be universes where mathematics itself works differently, where 2 plus 2 equals 5, where geometry follows rules that would make Euclid dizzy, where logic itself takes forms we cannot comprehend. The ancient Pythagoreans believed that all is number, that mathematical relationships were the fundamental reality underlying the physical world. They saw numerical ratios in the harmony of musical scales, geometric patterns in the movements of planets, mathematical relationships in the structures of living things. What they intuited thousands of years ago, modern physics has confirmed in remarkable detail. The universe appears to be mathematical at its deepest level, but if mathematics is the foundation of reality, then why should only one mathematical structure be privileged with actual existence? Why should our particular set of equations describing our particular arrangement of particles and forces and space-time geometry, be the only one that gets to be real? It's like asking why only one number should exist, when the logic of mathematics generates infinitely many numbers, each with its own properties and relationships. In the mathematical multiverse, consciousness becomes something like a spotlight that illuminates particular regions of mathematical space. You exist because there's a mathematical structure complex enough to support patterns of information processing that we recognize as consciousness. But there are other mathematical structures supporting other kinds of consciousness, other ways of experiencing existence that we can barely imagine. Some of these mathematical universes might be simpler than ours, realities governed by the rules of elementary arithmetic, or basic geometry, or simple cellular automata. Others might be vastly more complex, with mathematical structures so intricate that they support forms of consciousness and experience that make our richest thoughts seem primitive by comparison. There's something both humbling and elevating about this vision. Humbling, because it suggests that our entire physical universe, with all its galaxies and planets and living creatures, is just one note in an infinite mathematical symphony. Elevating, because it suggests that your consciousness is not an accident or side effect, but an essential feature of mathematical reality itself. You exist because mathematical structures that support consciousness must exist, and they must be experienced by conscious observers embedded within them. And here's something beautiful to consider. If the mathematical multiverse is real, then every thought you've ever had, every feeling you've experienced, every moment of wonder and curiosity and love, all of these exist, not just as fleeting neural patterns but as eternal features of mathematical reality. The structure that describes your consciousness having this thought at this moment is just as permanent and fundamental as the number pi or the square root of 2. As you drift towards sleep, you might think about the fact that, if mathematics is the deepest level of reality, then every dream you're about to have corresponds to some mathematical structure, some pattern of relationships and transformations that exists in the vast space of logical possibility. Your dreams aren't just neural noise, they're explorations of mathematical universes that exist whether anyone dreams them or not. The mathematical multiverse suggests that existence is not scarce, but abundant, not fragile but eternal, not accidental but necessary. Every possible thought exists somewhere in mathematical space. Every possible experience is embedded in some mathematical structure. Every possible story is written in the infinite library of mathematical reality. If we can't see them, can they still be real? There's a tree falling in a forest, right now, somewhere in the world. You can't hear it, you can't see it, you have no way of detecting it directly, but you don't doubt that it's real, do you? The sound waves ripple through the air, whether or not anyone is there to perceive them. The tree crashes to the forest floor, whether or not it makes any mark on human consciousness. We accept that reality extends far beyond the reach of our senses, but when it comes to other universes, realms that might be separated from us by quantum barriers, inflating space, extra dimensions, or mathematical abstraction, suddenly we become skeptical. If we can't see them, touch them, measure them with our instruments, can they really be said to exist? It's one of the deepest questions in the philosophy of science. What does it mean for something to be real? Traditional science has always had an uneasy relationship with unobservable phenomena. For centuries, atoms were considered useful fictions, mathematical tools that helped predict the behavior of gases and chemical reactions, but not necessarily real things in themselves. It wasn't until the early 20th century, when techniques were developed to detect individual atomic effects, that most scientists accepted atoms as physically real, rather than just conceptually useful. But the multiverse poses a more challenging problem. Other universes by definition are causally disconnected from ours. We can't send signals to them or receive signals from them. We can't build instruments to detect them directly. They leave no trace in our local physics experiments. If they exist in a way that is fundamentally beyond our ability to verify. This bothers some scientists deeply. They argue that science should stick to phenomena that can be observed, tested, and verified. Theories about unobservable universes, no matter how mathematically elegant, are more philosophy than physics. They're like medieval discussions about how many angels can dance on the head of a pin. Intellectually interesting perhaps, but not scientifically meaningful. But other scientists point out that this objection misunderstands how science actually works. We routinely accept the existence of unobservable phenomena if they're consequences of theories that make successful observable predictions. Quarks can't be isolated and observed directly, but we accept their reality because quantum chromodynamics, the theory that describes them, successfully predicts the behavior of particles we can observe. Black holes were accepted as real decades before we had direct evidence for them, because general relativity, a theory with many confirmed predictions, said they should exist. The Higgs boson was considered real by most physicists, long before the Large Hadron Collider detected it, because the standard model of particle physics required it, and the standard model had passed every other test we could devise. In the same way, multiverse theories aren't just idle speculation. They emerge as consequences of our best theories of quantum mechanics, cosmology, and fundamental physics. If we accept these theories because of their successful predictions in domains we can test, then we should also accept their predictions about domains we can't test directly. But there's a deeper philosophical question here. What do we mean by real in the first place? Consider your dreams from last night. They felt real while you were experiencing them. They involved characters, settings, narratives, emotions that seemed as vivid as anything in your waking life. When you woke up, you didn't say the dream characters were unreal, because they couldn't be observed by others. You said they were real experiences that happened to be internal rather than external. Perhaps the multiverse requires us to expand our notion of reality in a similar way. Perhaps real doesn't mean observable by us, but rather possessing the property of existence in some consistent logical framework. Mathematical objects like numbers are real in this sense. They exist as permanent features of logical space, even though you can't touch them or put them under a microscope. There's also something beautifully democratic about multiverse theories. They suggest that our particular corner of reality isn't privileged, that the physical laws we observe, the constants we measure, the historical events we've experienced, are just one instance of a much larger pattern. It's like discovering that Earth isn't the center of the universe, but on a much grander scale. Our entire universe might not be the center of reality. And here's something to ponder as you settle into sleep. If other universes exist but are unobservable, that doesn't make them less real. It just makes them less accessible. The light from distant galaxies takes billions of years to reach us, during which time those galaxies might have changed dramatically, or even ceased to exist. We're constantly interacting with the past, with things that are no longer there. Perhaps other universes are similar, real, but existing in a different kind of elsewhere than the spatial elsewhere of distant galaxies. The question isn't whether we can see other universes. The question is whether we can understand reality well enough to infer their existence from what we can observe. And if our best theories that work beautifully in every domain where we can test them, predict the existence of other universes, then perhaps those universes are as real as atoms were before we could see them, as real as black holes were before we could photograph them, as real as the tree falling in the forest that no one hears. Reality might be much larger and more generous than what we can directly perceive. The multiverse isn't asking us to believe in magic. It's asking us to trust that the logical consequences of successful scientific theories are as real as the theories themselves. Quantum decoherence, where possibilities become realities. Imagine you're in a room with 1,000 radios, each one tuned to a different station. At first, there's cacophony, overlapping music, voices, static, all mixing together in an incomprehensible jumble. But gradually, as you move through the room, one station becomes clearer and louder, while all the others fade into the background. By the time you reach the other side, you hear only one clear signal, even though all the other stations are still broadcasting. This is surprisingly close to what physicists think happens in quantum decoherence, the process that transforms the weird, multiple possibility world of quantum mechanics into the single definite reality we experience every day. It's the bridge between the quantum multiverse and our classical experience, and understanding it might be key to understanding how parallel realities work. In the quantum world, particles don't just have definite properties, they exist in superposition, simultaneously possessing multiple contradictory characteristics, until something forces them to choose. An electron can spin both clockwise and counterclockwise at the same time. A photon can pass through two different slits in a barrier simultaneously. These aren't just failures of our knowledge. According to quantum mechanics, these multiple states are physically real until the moment of measurement. But here's the puzzle: we never see superposition in our everyday lives. Coins don't spin heads and tails simultaneously, they land one way or the other. Cats aren't both alive and dead, like Schrödinger's famous thought experiment suggested. Something happens between the quantum scale and the classical scale that eliminates multiple possibilities and leaves us with single, definite outcomes. For decades, physicists thought this collapse of the quantum wave function was mysterious, perhaps even requiring consciousness or some special measurement process to trigger it. But quantum decoherence offers a more elegant explanation. The multiple possibilities don't disappear, they become isolated from each other through interaction with the environment. Think about that electron spinning in multiple directions simultaneously. In perfect isolation, it would remain in superposition forever. But in the real world, the electron interacts with photons, air molecules, electromagnetic fields, and countless other aspects of its environment. Each of these interactions is like adding more radio stations to our metaphorical room. They create interference patterns that separate the different quantum possibilities into distinct channels that can no longer influence each other. From your perspective as an observer, you become entangled with one particular channel, experiencing one definite outcome, but the other possibilities don't disappear. They continue existing in parallel channels that have become causally isolated from your experience. It's like being permanently tuned to one radio station while the others keep broadcasting in frequencies you can no longer access. This is how quantum decoherence supports the many worlds interpretation we explored earlier. Every quantum event doesn't just create one outcome, it creates all possible outcomes, each one unfolding in its own decoherent branch of reality. The multiverse isn't some exotic theoretical construct. It's the natural consequence of quantum systems interacting with their environments. But decoherence also explains why we don't notice parallel worlds in our daily lives. The more complex a system becomes, the faster it decoheres, separating into distinct branches that cannot interfere with each other. By the time you scale up from individual particles to cats and coins and human beings, decoherence happens almost instantaneously, making the different branches of reality effectively independent. There's something both comforting and unsettling about this picture. Comforting, because it explains why the world seems stable and definite, despite being built from quantum uncertainty. The classical reality we experience emerges naturally from quantum laws. We don't need any special collapse mechanism or conscious observers to make sense of everyday experience. But unsettling, because it suggests that this stability is somewhat illusory. The definite reality you experience, your memories, your identity, your life history, is just one branch in an ever-expanding tree of possibilities. Parallel versions of yourself are constantly being created through quantum decoherence, each one equally real from their own perspective, each one experiencing their branch as the real world, while the others fade into inaccessible parallel channels. Decoherence also offers a new perspective on the relationship between possibility and actuality. In classical physics, something is either real or unreal, actual or merely possible. But quantum decoherence suggests that all possibilities become actual in different branches. They just become isolated from each other in ways that prevent them from directly interacting. As you lie in bed tonight, quantum decoherence is happening in your brain with every neural firing, every molecular interaction, every quantum event in the biological machinery that creates your thoughts and dreams. Each of these events is spawning multiple branches of reality, creating countless parallel versions of this moment, each one slightly different from the others. But here's what makes it beautiful rather than terrifying. In each branch, a version of you is experiencing the wonder of existing, of thinking about these deep questions, of feeling the mysterious gift of consciousness in a quantum universe. Decoherence doesn't diminish the reality of your experience. It multiplies it infinitely, ensuring that every possible version of this moment of wonder gets to unfold somewhere in the vast tree of quantum possibility. The multiverse isn't somewhere else, it's right here, constantly branching through the quantum processes that underlie every aspect of physical reality, including the neural processes that are generating your thoughts about the multiverse right now. The anthropic principle: are we here because this universe works? Have you ever noticed how perfectly your hand fits around a coffee mug? Or how your eyes are positioned at just the right height to see over most obstacles while walking? These aren't cosmic coincidences, they're the result of evolution, which shaped your body to fit the environment you inhabit. But what if the same principle operates on a much grander scale? What if we find ourselves in a universe that seems perfectly suited for life, not because it was designed for us, but because we can only exist in universes where the conditions are just right? This is the essence of the anthropic principle, and it offers a fascinating perspective on why our universe appears to be fine-tuned for the existence of complexity, life, and consciousness. It's also one of the most compelling arguments for the reality of the multiverse. Not because we can prove other universes exist, but because they provide an elegant explanation for an otherwise puzzling feature of our own cosmos. The puzzle begins with the fundamental constants of physics, numbers like the strength of gravity, the mass of the electron, the rate of expansion of the universe. These values seem to be set with extraordinary precision, as if someone carefully adjusted cosmic dials to create conditions where atoms can form, stars can shine steadily for billions of years, planets can maintain stable orbits, and complex chemistry can unfold. Change the strength of gravity by even a tiny fraction, and stars would either burn out too quickly to allow life to evolve, or they'd be too cool to forge the heavy elements that make planets and biology possible. Adjust the mass of the electron slightly, and atoms couldn't exist. Modify the expansion rate of the universe, and matter would either be too spread out to form structures, or everything would have collapsed back into a big crunch long before life could emerge. For decades, this apparent fine-tuning puzzled physicists and philosophers. Some saw it as evidence for a cosmic designer, an intelligence that carefully set the dials to create a universe hospitable to life. Others argued it was just a remarkable coincidence, or perhaps evidence that the fundamental constants aren't really constant, but are determined by some deeper principle we haven't discovered yet. But the anthropic principle offers a different explanation, one that becomes particularly elegant if the multiverse is real. If there are countless universes with different values for the fundamental constants, then most of them would be sterile, unable to support stars, planets, chemistry, or life. But in the rare universes where the constants happen to fall within the narrow ranges that allow complexity to emerge, conscious observers like us can eventually develop and wonder about the apparent fine-tuning of their cosmos. We find ourselves in a life-friendly universe, not because all universes are life-friendly, but because we can only exist in the tiny subset of universes where the conditions are right. It's like winning the cosmic lottery. Not because the odds were in our favor, but because only the winners get to be surprised by their luck. This is sometimes called the weak anthropic principle, and it's relatively uncontroversial. But there's also a strong version that goes further, suggesting that the universe must have properties that allow consciousness to develop, because consciousness is somehow necessary for the universe to exist in the first place. This stronger version ventures into deep philosophical territory about the relationship between mind and reality. But even the weak version has profound implications for how we think about our place in the cosmos. If the anthropic principle is correct, then Earth-like planets, and perhaps life itself, might be far more common in the multiverse than we might expect from studying our single universe. In most universes, the constants wouldn't allow for any complexity at all, but in those rare universes where complexity is possible, it might emerge almost inevitably, filling the cosmos with life, and consciousness and wonder. There's something both humbling and inspiring about the anthropic perspective. Humbling, because it suggests that our existence depends on winning an almost impossibly unlikely cosmic lottery. The chain of circumstances that led from the Big Bang to the formation of galaxies to the birth of our sun, to the emergence of life on Earth, to the evolution of consciousness, might be so improbable that it could only happen in a tiny fraction of all possible universes, but inspiring because it suggests that your consciousness is not a trivial accident, but a rare and precious feature of reality. In the vast majority of possible universes, nothing interesting ever happens. No complexity emerges, no life develops, no minds arise to contemplate their own existence. But you're experiencing one of the exceptional universes where all of this became possible. Ancient philosophers often marveled at the apparent harmony between human reason and the mathematical structure of the cosmos. How is it, they wondered, that minds that evolve to hunt and gather and avoid predators are capable of understanding quantum mechanics and relativity? The anthropic principle offers an answer. We can understand the universe because we exist only in universes that are capable of producing understanding minds. As you drift towards sleep tonight, you might reflect on the extraordinary chain of cosmic coincidences that had to align for this moment to be possible. If gravity was stronger, if electrons were heavier, if the universe expanded faster, any one of countless different possibilities could have prevented this conversation from ever happening. But perhaps that's not the right way to think about it. Perhaps it's better to say that among all the possible conversations that could happen across all possible universes, this one, you here, now, contemplating the deep structure of reality, this one gets to happen because the cosmic constants in this universe allow minds to develop that are capable of having exactly this kind of wonder-filled conversation with existence itself. The holographic universe. Are we just a shadow of something else? Imagine watching shadows dance on a wall, figures moving and interacting in what appears to be a complete world of shadow beings. From their perspective, their two-dimensional wall might be all there is to reality. But you, observing from the third dimension, know that these shadows are projections of three-dimensional objects moving in a richer, fuller space that the shadow beings cannot directly perceive. What if we are those shadow beings? What if everything we experience, every star, every planet, every atom, every thought, is actually a kind of cosmic shadow cast by something more fundamental existing in a higher dimensional reality? This isn't just poetic metaphor, it's one of the most profound and counterintuitive ideas to emerge from modern physics, the holographic principle. The story begins with black holes, those mysterious regions where gravity becomes so strong that not even light can escape. In the 1970s, physicist Jacob Bekenstein made a startling discovery. The amount of information that can be stored in a region of space is not proportional to its volume, as you might expect, but to its surface area. It's like discovering that a book's contents are determined not by how thick it is, but by how large its cover is. This seemed bizarre until Stephen Hawking's work on black hole thermodynamics confirmed it. The entropy of a black hole, a measure of how much information it contains, is indeed proportional to the area of its event horizon, not its volume. It's as if all the information about everything that falls into a black hole gets encoded somehow on its two-dimensional surface. But if this is true for black holes, physicists wondered, might it be true for space in general? Could all the information in any three-dimensional region actually be encoded on its two-dimensional boundary? Could the rich, complex reality we experience in 3 dimensions of space actually be like a hologram, a projection from information stored on a distant two-dimensional surface? This led to one of the most audacious ideas in modern physics. Perhaps our entire universe, with all its depth and complexity, is actually a kind of holographic projection from information encoded on its boundary, a cosmic event horizon that surrounds everything we can observe. In this picture, the fundamental reality isn't the three-dimensional space filled with particles and fields that we think we inhabit. Instead, the fundamental reality is information patterns of data encoded on a two-dimensional surface that somehow projects our three-dimensional experience. We would be like characters in a cosmic hologram, experiencing depth and volume and movement that are actually emergent properties of flat information processing. It sounds like science fiction, but the holographic principle has found surprising support from several directions in theoretical physics. In string theory, physicists have discovered precise mathematical relationships between gravitational theories in higher dimensional spaces and quantum field theories on their boundaries, as if the higher dimensional reality is indeed somehow encoded in lower dimensional information. And in the attempt to understand quantum gravity, the theory that should describe what happens when quantum mechanics meets Einstein's general relativity, the holographic principle offers a new way of thinking about space and time themselves. Perhaps space isn't fundamental but emergent, like the way a melody emerges from the patterns of individual notes, or the way a story emerges from the arrangement of words. This has profound implications for multiverse theories. If our three-dimensional reality is actually a projection from two-dimensional information, then other arrangements of that information might correspond to other universes, other possible holographic projections with different physical laws, different histories, different ways of organizing matter and energy and consciousness. But the holographic principle also raises deep questions about the nature of consciousness and identity. If you are a pattern of information encoded on some cosmic boundary, what does that mean for your sense of being a unique individual existing at a particular location in space and time? Are your thoughts and memories and sense of self just part of the holographic projection, or do they exist more fundamentally in the information space that generates the projection? There's something both unsettling and liberating about this possibility. Unsettling because it suggests that the solid, three-dimensional world you inhabit might be a kind of illusion, real in terms of your experience, but not fundamental in terms of the deeper structure of reality. Liberating because it suggests that consciousness might be more fundamental than matter, that information and pattern and relationship might be the deepest levels of existence. Ancient Eastern philosophies often spoke of the physical world as Maya, illusion or projection, while pointing to deeper levels of reality that can only be perceived through contemplation and inner experience. The holographic principle offers a scientific echo of this ancient insight. Perhaps the material world is real as experience, but not fundamental as metaphysics. As you settle into sleep, you might consider that if the holographic principle is correct, then the neural patterns in your brain that are generating these thoughts are themselves holographic projections of information encoded somewhere on the boundary of space itself. Your dreams tonight might be explorations of different ways that fundamental information can be arranged and experienced, different possible projections in the vast space of holographic possibility. And perhaps that's what makes the holographic universe beautiful, rather than disturbing. It suggests that consciousness and information and pattern are not late arrivals in the cosmic story, but fundamental features of reality itself. You're not just a collection of particles that happens to be arranged in a way that creates awareness. You're a way that reality explores its own possibilities, a particular melody that existence plays to experience what it's like to be conscious in a holographic cosmos. Cosmic microwave echoes, signs of collisions with other realms. On a clear night, when you tune an old television to an empty channel, about 1% of the static you see is actually ancient light. Photons that have been traveling through space for nearly 14 billion years, carrying the afterglow of the Big Bang itself. This cosmic microwave background radiation fills every cubic inch of space, a gentle whisper from the universe's childhood that tells the story of how simple hydrogen and helium gradually cooled and condensed into the first atoms. For decades, this cosmic baby picture has been one of our most important windows into the early universe. It's remarkably uniform across the sky, nearly the same temperature in every direction we look, but with tiny fluctuations that eventually grew into the galaxies and galaxy clusters we see today. These fluctuations are like fossils of quantum uncertainty from the universe's first moments, stretched across the sky by cosmic inflation. But some cosmologists have begun to wonder whether these ancient patterns might contain evidence of something even more extraordinary, signs of our universe's interactions with other universes in the multiverse. If bubble universes occasionally collide or come close to each other during the period of eternal inflation, they might leave subtle signatures in the cosmic microwave background, like footprints in cosmic sand that we might be able to detect with careful observation. The idea is both elegant and audacious. During cosmic inflation, our universe was expanding exponentially, doubling in size again and again in tiny fractions of a second. But other bubble universes were undergoing their own inflationary episodes in the larger space that contains them all. Occasionally, mass of these expanding bubbles might have collided or brushed against each other, creating disturbances that would show up today as anomalies in the cosmic microwave background. These collisions wouldn't be violent in the way we usually think of cosmic catastrophes. They would be more like ripples, spreading across a pond when two bubbles floating on its surface briefly touch. But those ripples would carry information about the collision across vast distances, potentially reaching regions that would eventually become part of our observable universe. What would such a collision look like in today's sky? Theorists predict it might appear as a circular pattern in the cosmic microwave background, a ring of slightly different temperature that stands out against the otherwise random fluctuations. The size and intensity of the ring would depend on when the collision occurred and how energetic it was, but it would be permanent evidence that our universe once encountered another realm of existence. Several groups of astronomers have actually searched for these collision signatures, analyzing data from sophisticated space telescopes that have mapped the cosmic microwave background in unprecedented detail. The results are tantalizingly ambiguous. Some studies claim to have found circular patterns that might be collision signatures, while others argue that these patterns are within the range of what we'd expect from random fluctuations. But the search itself represents something remarkable about modern cosmology. We're now capable of looking for evidence of other universes in the baby pictures of our own cosmos. We're like archaeologists of the multiverse, sifting through ancient light for clues about whether our universe has siblings. There are other potential signatures to look for as well. If our universe formed through the collision of higher dimensional brains, as some string theory models suggest, that collision might have left its own distinctive fingerprints in the patterns of early cosmic structure. If our universe is part of an eternally inflating multiverse, there might be subtle correlations in the cosmic microwave background that reveal the fractal structure of bubble formation across cosmic history. Even the absence of certain signatures can be informative. The cosmic microwave background is remarkably smooth and uniform, which tells us something about the conditions during inflation. But different multiverse scenarios make different predictions about how smooth or structured these ancient patterns should be. So precise measurements can help us distinguish between competing theories. What's particularly beautiful about this approach is that it transforms abstract theoretical speculation into concrete observational science. The multiverse isn't just a philosophical idea anymore. It's a hypothesis that makes testable predictions about what we should observe in our own universe's most ancient light. And there's something poetic about the possibility that evidence of other universes might be written in the sky above us, encoded in radiation that has been traveling toward Earth since before the first stars formed. Every time you see static on an old television, you're glimpsing photons from the cosmic microwave background. And some of those photons might carry subtle traces of our universe's encounters with other realms. As you drift towards sleep tonight, you might think about the fact that the cosmic microwave background is not just around us but passing through us. Billions of photons from the early universe streaming through your body every second. If some of those photons carry information about collisions with other universes, then you are literally being bathed in evidence of the multiverse, even if we don't yet know how to read all the messages encoded in that ancient light. The cosmic microwave background transforms the multiverse from pure theory into detective story, where the clues are written in the oldest light in the universe, and the mystery is whether we live in a cosmos that has touched other realms of existence. Simulated universes. Are we a multiverse inside a computer? Picture yourself playing a video game with incredibly realistic graphics, characters that seem almost alive, landscapes that feel immersive, physics that behave just like the real world. Now imagine that technology advancing year after year, decade after decade, until the simulated worlds become indistinguishable from reality. The characters in the game develop their own thoughts, their own sense of identity, their own wonder about whether they might be living in a simulation. This thought experiment isn't just idle speculation. It's at the heart of one of the most discussed ideas in modern philosophy of mind, the simulation hypothesis. And if it's correct, then the multiverse might not be a collection of physical universes scattered across space and time, but rather a vast library of simulated realities running on computers in some higher level of existence. The argument, popularized by philosopher Nick Bostrom, follows a surprisingly rigorous logical structure. If civilizations eventually develop the computational power to run detailed simulations of their ancestors or alternative histories, and if they choose to run many such simulations, then simulated beings would vastly outnumber real beings. From a purely statistical perspective, any randomly selected conscious being would be more likely to exist within a simulation than in base-level reality. Consider the implications. If a single advanced civilization decides to run thousands or millions of detailed historical simulations, each one might contain billions of simulated people, each experiencing their simulated lives as completely real. The simulated beings would have memories, relationships, thoughts about the nature of existence, everything that makes consciousness meaningful, but they would exist as patterns of information rather than arrangements of atoms. And those simulated beings might themselves develop the technology to run their own simulations, creating nested layers of simulated realities stacked one inside another, like Russian dolls made of information. Each level might be completely unaware of the levels above it, experiencing their own reality as fundamental while actually existing as software running on computers that are themselves simulated. This creates a kind of computational multiverse, infinite or near infinite layers of simulated realities, each one as rich and complex as base-level reality, each one containing conscious beings who wonder about their place in the cosmos. Instead of parallel universes separated by space or dimensions, we would have parallel realities separated by levels of computational abstraction. The idea connects with ancient philosophical questions about the nature of reality and perception. Plato's cave allegory suggested that what we take to be reality might be just shadows cast by more fundamental forms. The Hindu concept of Maya treats the physical world as illusory, pointing toward deeper levels of reality that can only be accessed through spiritual practice. The simulation hypothesis offers a technological version of these ancient insights, but it also raises new questions that those ancient philosophies didn't have to address. If we are simulated, does that make our experiences less real or less meaningful? When you feel joy or sorrow, when you contemplate the beauty of a sunset or the wonder of existence itself, does it matter whether these experiences are generated by biological neurons or digital computations? Most philosophers and scientists who take the simulation hypothesis seriously argue that it doesn't diminish the reality of conscious experience. A simulated sunset might not involve actual photons and electromagnetic radiation, but the subjective experience of watching it, the feeling of beauty, the sense of wonder, the way it connects to your memories and emotions, that experience is just as real, whether it's generated by biology or computation. And if simulated universes can be just as real as physical ones, then the simulation hypothesis opens up extraordinary possibilities for the nature of existence itself. Simulated realities could have different physical laws, different histories, different possibilities for life and consciousness to develop. They could be vast explorations of alternative physics, alternative biology, alternative paths that consciousness might take through the space of all possible experiences. Some simulated universes might be historically accurate recreations of actual past events. Others might be pure fantasies, exploring what life would be like in universes with different constants of physics or different evolutionary histories. Still others might be experiments in consciousness itself, attempts to understand how awareness emerges from information processing and how it can be expanded or enhanced. There's something both humbling and empowering about the possibility that we might be simulated. Humbling, because it suggests that what we take to be the fundamental level of reality might actually be just one level in an infinite hierarchy of simulated worlds. Empowering, because it suggests that consciousness is so fundamental and precious that advanced civilizations would dedicate enormous resources to creating new forms and contexts for conscious experience. As you prepare for sleep, you might consider that if the simulation hypothesis is correct, then your dreams tonight are simulations within a simulation, nested layers of consciousness exploring the possibilities of experience within the computational substrate that generates both your waking and sleeping thoughts. And perhaps that's what makes the simulation hypothesis beautiful, rather than disturbing. It suggests that consciousness is not dependent on any particular physical substrate, but is a fundamental pattern that can emerge from any sufficiently complex information processing system. Whether you exist as patterns in neurons or patterns in silicon, the experience of being aware, of wondering about existence, of feeling connected to the mystery of being, that experience transcends the particular platform on which it runs. Black holes as portals to other universes. Picture this. You're standing at the edge of a bathtub, watching water spiral down the drain. The water moves faster as it gets closer to the center, creating a whirlpool that seems to lead somewhere else. Now imagine that drain is the size of a city, with gravity so intense that not even light can escape. Welcome to the strange world of black holes, those cosmic vacuum cleaners that might just be doorways to places we've never imagined. There's something almost magical about the idea, isn't it? That these dark, silent monsters lurking in space could be cosmic subway systems, connecting our universe to others. It sounds like science fiction, but some of our brightest minds have wondered the same thing. Einstein himself, that wild-haired dreamer who gave us relativity, stumbled upon equations that suggested something extraordinary. What if the fabric of space-time could fold in on itself like origami, creating shortcuts between distant places? When you fall past the event horizon of a black hole, that point of no return, where escape becomes impossible, something peculiar happens to time itself. From your perspective, everything seems normal. You're falling, perhaps thinking about whether you remembered to feed your cat before embarking on this rather extreme adventure. But to someone watching from far away, you appear to slow down, freeze, and gradually fade away like a ghost at sunrise. Time becomes elastic, stretching and bending in ways that would make a yoga instructor jealous. But here's where it gets deliciously mysterious. What happens after you cross that threshold? The equations break down into what physicists politely call singularities, mathematical tantrums, where numbers become infinite, and common sense takes a permanent vacation. Some theories suggest you don't simply get crushed into a point smaller than a grain of sand. Instead, you might emerge somewhere else entirely. Like Alice tumbling through her rabbit hole into Wonderland. The idea is a name that sounds appropriately sci-fi, the Einstein-Rosen bridge, though most people know it as a wormhole. Picture space-time as a sheet of paper. Normally, to get from one side to the other, you'd have to travel across the entire surface. But what if you could fold that paper in half and poke a hole through both layers? Suddenly, you have a shortcut, a tunnel through the very fabric of reality. Leonard Susskind, a physicist with the kind of beard that suggests deep thoughts about the universe, proposed something even wilder. He suggested that when information falls into a black hole, it doesn't disappear forever. Instead, it gets encoded on the black hole's surface like a cosmic hologram. But what if that information represents something far more extraordinary than we imagined? What if it represents entire universes, nested inside each black hole, like Russian dolls of reality. The mathematics of black holes reveal something that feels almost too strange to be true. They have temperature and entropy, just like a warm cup of coffee cooling on your kitchen counter. Stephen Hawking, that brilliant mind trapped in a failing body, showed us that black holes actually evaporate over time, radiating particles into space like cosmic steam rising from a universal hot tub. But where does that radiation come from? Some theories suggest it comes from the collision of particles and antiparticles right at the event horizon, where reality becomes deliciously uncertain. And that brings us to perhaps the most mind-bending possibility of all. What if our entire universe exists inside a black hole in some larger parent universe? It's like discovering you've been living inside a snow globe all your life, sitting on the mantelpiece of some cosmic giant, the Big Bang. That moment when our universe burst into existence from a point smaller than a period at the end of this sentence might not have been a beginning at all, but rather the inside view of matter collapsing into a black hole in another dimension. Lee Smolin, a physicist who thinks about time like a poet, thinks about words, proposed this very idea. He called it cosmological natural selection, suggesting that universes reproduce by creating black holes, each one potentially giving birth to a new cosmos with slightly different physical laws. Its evolution on a scale so vast it makes Darwin's finches look like a gentle afternoon stroll through biology. The beauty of this idea is how it addresses one of cosmology's most awkward questions: why are the laws of physics in our universe so perfectly tuned for the existence of stars, planets, and ultimately, curious creatures like us, who wonder about such things? If black holes create new universes with randomly varied physical constants, then the ones that survive and thrive are those with laws that allow for complexity, structure, and eventually life. It's like a cosmic game of trial and error, played out across dimensions we can barely imagine. But here's the delicious frustration: we can't simply pack a lunch and dive into the nearest black hole to test these ideas. The closest one, called Sagittarius A, sits at the center of our galaxy like a cosmic lighthouse keeper, about 26,000 light-years away. Even if we could somehow survive the journey, dodging cosmic radiation, avoiding the awkward problem of aging to death before arriving, and somehow not getting spaghettified by tidal forces, we'd have no way to send back a postcard saying "Greetings from the multiverse, weather is strange. Wish you were here." So we're left to probe these mysteries with mathematics and thought experiments. Like blind people trying to understand an elephant by touch. We can feel the curves of the equations, trace the strange topology of bent spacetime, and glimpse shadows of possibilities that dance at the edge of what we can comprehend. The math suggests these portals might exist. But math has been known to be beautifully wrong before, and perhaps that's part of what makes the idea so compelling. In a universe that often feels cold and indifferent, the possibility that black holes might be cosmic doorways adds a touch of magic to the darkness. Every time you look up at the night sky and think about those invisible monsters lurking between the stars, you might be looking at the universe's own hidden transportation system, a cosmic metro map written in the language of gravity and space-time, time loops and multiversal intersections. Have you ever had one of those mornings where you wake up and, for just a moment, you're not quite sure what day it is? Maybe it's Monday, or maybe it's still Sunday, or perhaps you've somehow slipped sideways into last Thursday. That feeling of temporal displacement, that brief vertigo when time feels negotiable, might be more than just sleepy confusion. It might be a glimpse into one of the universe's most elegant possibilities, that time itself could loop, spiral, and intersect in ways that would make a pretzel jealous. Time, as we usually experience it, feels like a river flowing in one direction, from past to future, carrying us along, like leaves on the current. But what if that's just an illusion? Like thinking the Earth is flat, because we can't see its curvature from where we stand. What if time is actually more like a vast, complex highway system, with loops, intersections, and the occasional cosmic traffic jam where multiple timelines converge? The idea of time loops has fascinated physicists ever since Einstein showed us that time is not the steady, universal metronome we thought it was. In his theory of general relativity, time becomes elastic, stretching and compressing depending on gravity and motion. And if time can bend, well, then maybe it can fold back on itself, like a cosmic origami crane. Kurt Gödel, that brilliant logician who spent his later years afraid that someone might poison his food, discovered something extraordinary hidden in Einstein's equations. He found solutions that allowed for what he called closed time-like curves, paths through space-time that loop back to their starting point. Imagine drawing a circle on a piece of paper, but instead of returning to the same place in space, you return to the same moment in time. It's like taking a very long walk and arriving at yesterday. But here's where it gets deliciously complicated. If time can loop, and if there really are multiple universes, then perhaps these loops are where different realities intersect. Picture two soap bubbles floating in the air, our familiar universe, and some alternate version, where you decided to become a professional juggler instead of whatever you actually do. Most of the time these bubbles float independent, but occasionally they touch, creating a brief connection where information or perhaps even consciousness could slip between worlds. The mathematics of this possibility reads like poetry written by the universe itself. In quantum field theory, particles can tunnel through barriers they shouldn't classically be able to cross. It's like watching a marble roll uphill when no one's looking. Similarly, quantum effects might allow information or even entire timelines to leak between universe bubbles at their intersection points. These cosmic meeting places could appear as loops in time, moments where the past and future fold together like lovers' hands. Interestingly, some physicists have wondered whether déjà vu, that eerie feeling that you've lived this exact moment before, might be evidence of these temporal intersections. Maybe when you walk into a coffee shop and suddenly feel like you've had this precise conversation with the barista before, you're actually remembering a loop where another version of you, in another universe, is living through a slightly different version of the same moment. It's like catching a glimpse of your reflection in a cosmic hall of mirrors. The many worlds interpretation of quantum mechanics adds another layer to this mystery. Every time a quantum event occurs, which is constantly at every moment in every atom, the universe splits into multiple branches, each one exploring a different possible outcome. Hugh Everett III, who dreamed up this idea while still a graduate student, imagined these branches spreading out like the limbs of an infinite tree. But what if some of these branches eventually curve back and reconnect, creating loops in the grand structure of reality? Richard Feynman, that physics rock star who played bongo drums and cracked safes for fun, once described particles as taking every possible path through space simultaneously. When a photon travels from point A to point B, it doesn't just take the shortest route, it explores all possible trajectories, like a tourist who can't decide between the scenic route and the highway. Most of these paths cancel each other out through quantum interference, but they all contribute to the particle's final destination. Now imagine applying this principle to entire timelines. Perhaps every possible history plays out simultaneously, with some paths looping back to create closed circles in time. The history where you became an astronaut might eventually curve back to intersect with the timeline where you became a baker, creating a moment of convergence where both possibilities briefly coexist. It's like watching all the chapters of your life story happen at once, with occasional overlap where the plots interweave. The practical implications of this idea stretch the imagination. If time loops exist, and if they connect different branches of the multiverse, then perhaps consciousness could occasionally slip between them like water finding a crack in a dam. Those moments of inexplicable intuition, when you suddenly know something you couldn't possibly know, might be your awareness briefly accessing information from a parallel timeline. Carl Jung, that explorer of the human psyche, proposed the idea of synchronicity, meaningful coincidences that seem to suggest an underlying pattern in reality. Maybe these synchronicities are evidence of multiversal intersections, moments when the boundaries between different realities become permeable. That book you randomly picked up that contained exactly the information you needed. That chance encounter with a stranger who changed your perspective. Perhaps these aren't coincidences at all, but glimpses of how interconnected the multiverse really is. Of course, the universe has a sense of humor about such things. If time loops really existed and connected different realities, they would create paradoxes that would make a philosophy professor reach for a strong drink. What happens if you use information from one timeline to prevent an event in another? Do the loops stabilize into self-consistent patterns, or do they create cascading changes that ripple through the entire multiverse like dominoes falling in cosmic slow motion? Some physicists have suggested that the universe might have built-in protection against paradoxes, what they call the Novikov self-consistency principle. It's the idea that the universe naturally arranges itself so that any time loop becomes self-consistent, like a story that writes itself to avoid plot holes. If you tried to go back and change something, events would conspire to ensure that your intervention was always part of how things happened in the first place. But perhaps the most beautiful aspect of temporal loops in the multiverse is how they suggest that all of time, past, present, and future might exist simultaneously in some higher dimensional space. From our limited perspective, we experience one moment after another like reading a book page by page, but maybe the complete story already exists, written in the geometry of space-time itself, with loops and intersections creating a vast, interconnected narrative where every possible moment touches every other, dreams, déjà vu, and the echoes of other worlds. Close your eyes for a moment and think about the strangest dream you've ever had. Maybe you were flying through impossible architectures, or having deep conversations with people who don't exist, or living in a world where the laws of physics took a holiday. When you woke up, you probably dismissed it as just your brain sorting through the day's debris, like a cosmic janitor cleaning up neural clutter. But what if that dream wasn't random neural noise at all? What if it was actually a window into another reality? A brief glimpse of how things might have unfolded in a universe just slightly different from our own. Dreams have puzzled humans since we first started wondering about the world around us. Ancient cultures saw them as messages from gods, or glimpses of future events. Modern neuroscience tells us they're the brain's way of consolidating memories and processing emotions, but perhaps both explanations are touching different parts of the same elephant. Maybe dreams are memory consolidation and messages from alternate selves, all wrapped up in one extraordinary nightly experience. The quantum nature of consciousness remains one of science's most delicious mysteries. Some researchers, like Roger Penrose and Stuart Hameroff, have proposed that consciousness might operate according to quantum principles, that our awareness itself might exist in a state of quantum superposition until the moment of observation collapses it into definite experience. If consciousness really does dance to quantum rhythms, then perhaps during sleep, when the filters of waking awareness relax their grip, our minds might tune into other frequencies of reality. Think about how dreams feel different from waking thought. In dreams, you can be simultaneously yourself and someone else entirely. You can be in two places at once, experience impossible geometries, and accept contradictions that would make your waking mind revolt. This might not be a bug in the system, it might be a feature. Maybe the dreaming brain, freed from the constraints of processing immediate sensory input, naturally resonates with the quantum possibilities that surround us at every moment. The many worlds interpretation suggests that every quantum event splits reality into multiple branches, each exploring a different outcome. If consciousness has quantum properties, then perhaps during the fluid state of dreaming, our awareness occasionally leaks across these branches like water seeping through a membrane. That dream where you lived in a house you've never seen but felt completely familiar might be a memory borrowed from an alternate you who actually made different choices and ended up in different circumstances. And that brings us to déjà vu, that ghostly feeling of having lived through this exact moment before. Nearly everyone has experienced it. You walk into a room, hear a specific conversation, smell a particular scent, and suddenly feel like you're watching a rerun of your own life. Neurologists usually explain it as a glitch in memory processing, like your brain accidentally filing a new experience in the already happened folder. But what if it's actually the opposite? A moment when your consciousness briefly recognizes a scene from another branch of reality? Henri Bergson, that French philosopher who thought about time like a river and memory like a vast library, proposed that our brains might be more like radio receivers than computers. Instead of generating consciousness, maybe they tune into it, selecting from a vast field of potential experiences. If that's true, then déjà vu might be moments when the radio picks up signals from adjacent stations, brief glimpses of parallel versions of our lives playing out in neighboring realities. The phenomenon becomes even more intriguing when you consider how often déjà vu occurs at emotionally significant moments. It rarely happens when you're doing something mundane like folding laundry or paying bills. Instead, it tends to occur during conversations that matter, in places that feel meaningful, at moments when life seems to be shifting direction. Maybe these are precisely the times when the boundaries between realities become most permeable, when the gravitational pull of important events creates resonances across the multiverse. Carl Jung wrote about what he called the collective unconscious, a shared psychological space that connects all human minds. He believed we could access universal symbols and archetypal patterns through dreams and unconscious experiences. But what if Jung was touching on something even more profound? What if the collective unconscious is actually a form of multiversal consciousness, a way of accessing the experiences and wisdom of our other selves across different realities. This idea gains support from the strange similarities that often appear in the dreams and experiences of people who have never met. Why do humans across cultures dream of flying, falling, being chased, or arriving late for important exams? Traditional psychology suggests these are universal fears and desires, but maybe they're actually shared experiences, memories leaking through from realities where these scenarios play out differently for different versions of ourselves. The phenomenon of lucid dreaming, becoming aware that you're dreaming while still in the dream state, offers another tantalizing clue. Lucid dreamers report being able to consciously navigate dream landscapes, make decisions, and even communicate with dream characters who seem to have their own autonomous existence. Some experienced lucid dreamers describe encounters with versions of themselves who seem to remember different life histories, as if they're meeting alternate selves from parallel timelines. Tibetan Buddhists have practiced dream yoga for centuries, treating the dream state as an opportunity to explore the nature of reality itself. They speak of the bardo, transitional states between different forms of existence where consciousness can move more freely between dimensions of experience. Perhaps what they discovered through meditation and practice is what quantum physics is now suggesting through mathematics, that consciousness might not be as tightly bound to a single reality as we usually assume. The timing of when we experience these multiversal echoes might not be random either. Research on circadian rhythms shows that our brains cycle through different states of consciousness throughout the day. The boundary between sleep and waking, those drowsy moments when you're not quite sure if you're still dreaming, might be when the filters between realities are thinnest. That's often when people report the most vivid instances of déjà vu, the strangest synchronicities, and the most profound dreams. Even the content of our dreams might carry information from other realities. Dreams often feel prophetic, showing us scenes that later play out in waking life with eerie accuracy. Maybe this isn't precognition in the mystical sense, but rather consciousness accessing information from realities where similar events have already occurred. If all possible timelines exist simultaneously in some higher dimensional space, then perhaps dreams are like previews of coming attractions, glimpses of how events might unfold based on patterns already playing out elsewhere in the multiverse. The implications stretch far beyond personal experience. If dreams and déjà vu are really windows into other realities, then perhaps human consciousness is far more interconnected than we realize. Maybe every night, as billions of minds slip into sleep and begin to dream, we're all participating in a vast unconscious conversation across the boundaries of space and time, sharing information and experiences across the infinite branches of what might be. Can consciousness tap into parallel universes? Imagine, for just a moment, that your consciousness is like a radio antenna. Not the clunky metal kind on old cars, but something far more elegant and sensitive, capable of tuning into frequencies that exist beyond the normal spectrum of human experience. Right now, as you read these words, thousands of radio waves are passing through your body, carrying music, conversations, and data from around the world. You don't notice them because your biological antenna isn't tuned to those frequencies. But what if, with the right kind of attention, you could adjust the dial? This isn't entirely fantasy. The human brain, after all, is an electrochemical symphony, generating measurable electrical fields that extend beyond the skull. Every thought, every moment of awareness, creates ripples in the quantum field that surrounds us. Most scientists would say these fields are too weak to do anything meaningful beyond the boundaries of our own neural networks. But some researchers have begun to wonder, what if consciousness operates on principles we haven't fully understood yet? Roger Penrose, that mathematical physicist who thinks about black holes like poetry, has proposed that consciousness might emerge from quantum processes in tiny structures called microtubules, found within brain cells. These microscopic tubes, smaller than anything you could see with a traditional microscope, might be where quantum effects become amplified enough to influence the macro world of human thought and experience. It's like discovering that your brain contains millions of tiny quantum computers, each one potentially capable of processing information in ways that classical physics says should be impossible. If Penrose is right, then consciousness doesn't just emerge from the brain, it participates in the quantum dance that underlies all reality. And if quantum mechanics really does create multiple parallel universes every time a quantum event occurs, then perhaps consciousness, being quantum in nature, isn't confined to just one branch of reality. Maybe it naturally spans multiple universes, like a tree with roots in one world and branches extending into others. Stuart Hameroff, an anesthesiologist who became fascinated by consciousness while watching patients slip in and out of awareness, has worked with Penrose to develop this idea. They suggest that anesthesia doesn't just shut down brain activity, it disrupts quantum coherence in those microscopic microtubules, temporarily disconnecting consciousness from its quantum substrate. When patients report near-death experiences during surgery, perhaps what they're describing isn't hallucination, but consciousness temporarily freed from its usual constraints, able to access information from realities normally hidden from view. The phenomenon of intuition offers another intriguing clue. We've all had those moments when we suddenly know something without knowing how we know it, when a solution to a problem appears fully formed in our minds, or when we get an inexplicable feeling about a person or situation that later proves accurate. Traditional psychology explains intuition as the brain's ability to process subtle patterns below the threshold of conscious awareness. But what if it's actually consciousness accessing information from parallel versions of ourselves who have already encountered similar situations? Think about those times when you've had to make a difficult decision, weighing different options and trying to predict their outcomes. In the many worlds interpretation of quantum mechanics, every possible choice you might make actually does get made, each possibility spawning its own branch of reality. Maybe the feeling we call intuition is actually a form of quantum communication with these other versions of ourselves, a way of accessing their experiences to inform our choices in this reality. This idea gained support from research on what psychologists call thin-slice judgments, our ability to make remarkably accurate assessments about people or situations based on minimal information. Malcolm Gladwell wrote about this phenomenon in Blink, describing how the unconscious mind can process complex patterns in milliseconds, often outperforming careful analytical thought. But perhaps what we call unconscious processing is actually consciousness accessing a vast database of experiences from parallel selves who have encountered countless variations of similar situations. Meditation traditions from around the world have long claimed that consciousness can transcend its normal boundaries through various practices. Advanced meditators report experiences of expanded awareness, moments when the sense of individual self dissolves, and they feel connected to something vast and universal. Neuroscientists studying these states have found measurable changes in brain activity, including increased coherence between different brain regions and altered patterns of neural connectivity. But maybe these altered states aren't just changes in brain function. Maybe they're moments when consciousness tunes into different frequencies of reality. The Tibetan concept of rigpa, or pure awareness, describes a state of consciousness that exists beyond individual thought and perception. What if rigpa is actually consciousness accessing its quantum nature, momentarily stepping outside the constraints of a single timeline to experience the broader multiversal context in which we exist? The placebo effect presents another fascinating puzzle. How can simply believing a treatment will work sometimes create real, measurable changes in physical health? The standard explanation involves expectation influencing brain chemistry, which then affects the body's healing processes. But what if there's more to it? What if consciousness can literally tune into realities where the healing has already occurred, bringing that information back to influence this timeline? Some researchers have begun investigating whether consciousness might operate through what they call morphic resonance, the idea that similar patterns of experience create resonant fields that can influence future similar patterns. Rupert Sheldrake, a biologist who asks uncomfortable questions that make other scientists squirm, has proposed that when organisms learn new behaviors, they somehow make it easier for other similar organisms to learn the same behaviors, even across vast distances with no physical connection. If consciousness really can tap into parallel universes, it would help explain some of the most puzzling phenomena in human experience. Why do similar breakthrough discoveries often occur simultaneously in different parts of the world, by researchers who have no contact with each other? Why do certain ideas seem to emerge across cultures at particular historical moments, as if they're being transmitted through some invisible network? Perhaps the most profound implication is what this might mean for human potential. If consciousness isn't limited to a single brain in a single reality, then maybe the boundaries we assume exist around individual minds are more like suggestions than absolute walls. Maybe what we call genius isn't just exceptional individual intelligence, but the ability to access information and insights from a broader range of parallel selves. The challenge, of course, is learning how to tune the antenna more precisely. Most of the time, we're probably receiving a kind of quantum static, overlapping signals from countless parallel realities that create noise rather than useful information. But perhaps, through practices like meditation, creative work, or simply paying closer attention to moments of intuition and synchronicity, we can learn to distinguish meaningful signals from background noise. And maybe that's already happening more than we realize. Every moment of inspiration, every creative breakthrough, every time we solve a problem in a dream, or have a sudden insight while walking in nature, we might be tapping into the vast intelligence of our multiversal selves, accessing the wisdom and experience of infinite parallel lives to navigate this one reality with greater skill and understanding. Multiverse morality. What does right mean when there are infinity? Picture yourself standing at a crossroads, not the romantic, mystical kind with ancient signposts pointing to distant kingdoms, but the everyday kind we all face. Maybe it's deciding whether to tell a white lie to spare someone's feelings, or choosing between personal success and helping a colleague, or simply wondering whether to adopt that homeless kitten that's been hanging around your doorstep. In our familiar single-universe moral framework, you wrestle with the decision, perhaps lose some sleep, and eventually choose a path, living with the consequences of that choice. But what if, in the grand theater of the multiverse, you don't actually have to choose? What if every possible decision you might make gets made, each one spawning its own branch of reality where a different version of you lives with different consequences? Suddenly, that agonizing moral choice becomes something far stranger. Every possible version of you is exploring every possible ethical path simultaneously. This isn't just philosophical navel-gazing. It's one of the most profound challenges the multiverse presents to how we think about right and wrong. If the many worlds interpretation is correct, then at every moment when you face a moral decision, reality splits into branches. In one universe, you tell the truth and deal with the painful aftermath. In another, you lie and live with the guilt. In a third, you find some creative middle path that somehow satisfies everyone involved. Each version of you experiences their choice as the only real one, carrying the full weight of moral responsibility. David Lewis, a philosopher who spent his career thinking about possible worlds, pushed this logic to its almost absurd conclusion. He argued that all possible worlds are equally real, that our universe has no special status beyond being the one we happen to inhabit. If Lewis is right, then the version of you who becomes a saint and the version who becomes a criminal are both equally real, both living out their choices with the same intensity of experience you're having right now. This creates what philosophers call the moral indifference problem. If every possible action gets taken by some version of you in some branch of reality, then does it really matter which choice you make in this branch? After all, the total sum of good and evil actions across all realities remains constant. You can't reduce the total amount of suffering in the multiverse because every possible form of suffering is already happening somewhere. But perhaps that's looking at it backwards. Maybe the real question isn't whether your choices matter to the multiverse as a whole, but whether they matter to the specific branch of reality you're creating through those choices. When you choose kindness over cruelty, you're not just performing an isolated action. You're steering your branch of reality toward becoming a universe where kindness prevails. The version of you who chooses differently is creating a different kind of universe entirely. This perspective transforms moral responsibility from something you carry as an individual into something you co-create with every other conscious being in your reality branch. Every act of compassion you perform doesn't just help the immediate recipient, it contributes to making your universe the kind of place where compassion is possible and valued. You become a collaborator in the grand project of creating a reality worth inhabiting. Emmanuel Levinas, that profound thinker about ethics and human relationships, wrote about the face of the other, how looking into another person's eyes creates an immediate, undeniable moral responsibility. But if the multiverse is real, then every time you encounter another person, you're meeting just one version of them out of countless possibilities. The homeless person asking for help on the street corner. In some realities they're a saint, in others a criminal, in still others a lost genius who could change the world with the right opportunity. This multiplicity doesn't diminish the moral weight of the encounter, it amplifies it. You're not just choosing how to treat this specific version of this person, you're choosing what kind of universe to live in, what kind of story your branch of reality will tell about how conscious beings treat each other when they meet at the intersections of their lives. The question of moral luck becomes even more complex in a multiversal context. In our single-universe thinking, we wrestle with whether people can be held fully responsible for actions influenced by circumstances beyond their control. But if every possible circumstance plays out somewhere in the multiverse, then moral luck becomes cosmic. There are branches where you're born into circumstances that make virtue easy, and others where every choice is between different forms of harm. Perhaps this suggests that judgment itself needs to evolve. Instead of asking whether someone is fundamentally good or bad, maybe we should ask, given the circumstances of their branch of reality, how are they choosing to shape the universe they inhabit? The person who shows small kindnesses despite being raised in cruelty might be performing a greater moral feat than the person who gives millions to charity after being born into wealth and love. Buddhist philosophy has long grappled with similar paradoxes through the concept of karma, the idea that actions have consequences that ripple across lifetimes and states of being. If consciousness really does span multiple realities, then maybe karma isn't just about individual spiritual development, but about how the choices made by different versions of ourselves across different realities influence the overall pattern of consciousness throughout the multiverse. The implications for concepts like justice become equally complex. In a single universe, we seek to balance the scales, to ensure that good actions are rewarded and harmful ones have consequences. But in a multiverse where every possible outcome occurs, what does justice even mean? Perhaps it's not about balancing individual scales, but about contributing to branches of reality where justice and fairness have the best chance to flourish. This might explain why moral intuitions often seem to transcend purely rational calculation, that feeling you get when something is just wrong, even if you can't articulate exactly why. Maybe that's your consciousness resonating with the experiences of your other selves across multiple realities, accessing a kind of multiversal wisdom about which choices lead to flourishing and this lead to suffering. Free will, that ancient puzzle about whether our choices are truly free or merely the inevitable result of prior causes, takes on new dimensions in a multiverse. If every possible choice gets made by some version of you, then perhaps free will isn't about having the power to select which action occurs. It's about having the power to determine which branch of reality you'll inhabit, which version of yourself you'll become. And maybe that's the most profound moral insight the multiverse offers. You are constantly creating yourself through your choices, not just as an individual, but as a reality. Every moment of compassion, every act of courage, every decision to see the humanity in others is simultaneously a personal choice and a cosmic one, a vote for what kind of universe deserves to exist. In this view, morality becomes less about following rules and more about participating consciously in the ongoing creation of reality. You're not just trying to be good in some abstract sense, you're trying to nudge your branch of the infinite multiverse toward becoming the kind of place where consciousness can flourish, where beings can meet each other with recognition and care, where the vast potential of existence gets expressed through love rather than fear. The God question. Theology in a multiverse. There's something deeply unsettling about infinity, isn't there? Try to imagine the largest number you can think of, then realize that it's not even a whisper compared to true mathematical infinity. Now, take that feeling, that vertigo when the mind touches something too vast to grasp, and apply it to the possibility that reality itself might be infinite, branching endlessly into every conceivable possibility. If the multiverse is real, then somewhere in that vast expanse of realities, every possible relationship between the divine and the created is playing out simultaneously. For most of human history, theology has wrestled with questions about a single universe. Why does God allow suffering? How can free will coexist with divine omniscience? What does it mean to be chosen or blessed in a world where so many experience hardship? These questions become almost impossibly complex when multiplied across infinite realities, each containing its own version of these eternal puzzles. Consider the classical problem of evil. If God is all good, all-knowing and all-powerful, why does suffering exist? Theologians have offered various explanations. Suffering builds character, free will requires the possibility of choosing wrongly. Our limited perspective can't comprehend divine purpose, but in a multiverse, every possible answer plays out simultaneously. There are realities where suffering serves divine purposes, others where it doesn't, still others where different concepts of divinity operate according to completely different principles. Perhaps the most profound shift is how the multiverse affects the notion of divine choice and intervention. Traditional theology often depicts God as making specific decisions, choosing certain people for certain roles, intervening in particular moments, answering some prayers while allowing others to go seemingly unheeded. But if every possible divine action occurs somewhere in the multiverse, then God isn't making choices in the way we usually understand them. Instead, divine nature might be expressing itself through the totality of all possibilities, like an infinite symphony where every possible note and rhythm exists simultaneously. This transforms prayer from petition to something more like tuning. Instead of asking God to change circumstances in your specific reality, prayer might be about aligning your consciousness with the branches of the multiverse where divine love and wisdom are most clearly expressed. The mystics of various traditions have always described prayer less as asking for things and more as opening oneself to connection with the sacred. In a multiversal context, that opening might literally be about accessing realities where the presence of the divine is more readily apparent. The question of whether God exists becomes radically reframed in a multiverse. Instead of a binary yes or no answer, we might ask, in how many realities does God exist? And what does existence even mean for a being that might transcend the boundaries between universes? If consciousness can span multiple realities, then perhaps divine consciousness operates on an even more fundamental level, existing as the substrate from which all possible universes emerge. Some theologians have begun to explore what they call multiversal theology, the idea that God might be the very principle that generates infinite possibilities, the creative force that ensures every potential reality has the opportunity to unfold. In this view, the multiverse isn't separate from God but is rather how divine creativity expresses itself, an endless exploration of what it means to exist, to love, to suffer, to transcend, to create meaning in the face of vastness. The Kabbalistic tradition speaks of the Ein Sof, the infinite, boundless aspect of divinity from which all creation emanates. The multiverse might be the ultimate expression of Ein Sof, an infinite manifestation where every possible way of being gets explored. Each universe becomes a unique meditation on existence, the particular way that consciousness can organize itself into patterns of beauty, meaning, and relationship. This perspective offers a fascinating resolution to the problem of religious diversity. If every possible relationship with the divine is playing out somewhere in the multiverse, then perhaps different religious traditions aren't competing truth claims, but rather different windows into the infinite nature of divine reality. The Christian mystic experiencing union with Christ, the Sufi dissolving into divine love, the Buddhist discovering the emptiness that contains all fullness. Maybe these are all genuine encounters with different aspects of a multiversal divine presence. But this raises uncomfortable questions too. If every possible universe exists, then there are realities where the most beautiful religious experiences unfold alongside others, where the most horrific perversions of faith cause untold suffering. There are universes where religion inspires profound compassion, and others where it justifies terrible cruelty. The multiverse contains infinite versions of every religious tradition, some wise and loving, others twisted and destructive. Perhaps this is where the concept of divine judgment takes on new meaning. Rather than a single moment when souls are sorted into categories of saved and damned, judgment might be the ongoing process by which realities sort themselves according to their spiritual quality. Universes where consciousness evolves toward greater love, wisdom, and interconnection might naturally align with divine purposes, while those dominated by hatred, ignorance, and separation create their own forms of spiritual exile. The notion of salvation, too, transforms in a multiversal context. Traditional Christianity speaks of salvation as rescue from sin and death, a transition from separation to union with God. But if every possible spiritual journey is unfolding simultaneously across infinite realities, then perhaps salvation isn't a single event, but an ongoing process of consciousness awakening to its multiversal nature. Each moment of genuine spiritual growth, each choice to love rather than fear, to forgive rather than condemn, to see unity underlying apparent separation, might be consciousness participating in its own salvation across multiple realities. Reincarnation, a concept central to many Eastern traditions, becomes almost redundant in a multiverse where every possible life is lived simultaneously. Instead of consciousness moving from one lifetime to another in sequence, perhaps it experiences all possible lifetimes simultaneously across different branches of reality. What we call spiritual evolution might be consciousness gradually becoming aware of its vast multiversal identity, recognizing itself in the countless forms it takes across infinite realities. The idea of divine providence, God's guidance and care for creation, also shifts dramatically. Instead of God intervening in specific moments within a single timeline, providence might be the very structure of the multiverse itself, ensuring that every possible path of spiritual development gets explored. The hardships in your particular reality aren't evidence of divine indifference, but part of a vast tapestry where every form of growth, challenge, and transcendence finds expression. Prayer, in this context becomes less about changing external circumstances and more about shifting your awareness to realities where divine presence is more readily apparent. The peace that sometimes comes during prayer might not be God changing your situation, but your consciousness touching branches of the multiverse where that peace has always existed. Meditation becomes a practice of exploring the vast space of possible ways of being aware, discovering forms of consciousness that exist beyond the particular constraints of your immediate reality. And perhaps this is where the multiverse offers its most profound theological insight. The recognition that the sacred isn't separate from the ordinary, but is the very ground from which all possibilities emerge. Every moment of love, every flash of beauty, every experience of transcendence that occurs in any universe is simultaneously a unique, precious occurrence and an expression of something infinite and eternal that underlies all existence. The mystics have always insisted that separation from the divine is ultimately an illusion, that what we seek is not distant but is the very nature of our being. In a multiverse, this mystical insight becomes almost literally true. Consciousness in all its forms is always already expressing divine nature, exploring infinite ways of knowing and being known, creating an endless conversation between the finite and the infinite that we call reality.